Hello, algebra students. Mr. Lawrence here, and this is your second scientific notation video. This one is on multiplying and dividing by scientific notation. Now, believe it or not, you already know how to do this. Yeah, you sure do. Look at this black problem here. The quantity of 3x to the 4th times quantity of 6x to the 5th. Well, in that problem, wouldn't you multiply the 3 times the 6 and get 18? And x to the 4th times x to the 5th, and you get x to the 9th, right? I'm going to do this problem very much the same way. I'm going to treat this, I'm going to multiply 6 1/4 by 3 14/100ths, and then I'm going to multiply the 10 to the 5th by the 10 to the 8th. Now I'm going to keep in mind that my final answer to be in scientific notation will have to be greater than or equal to 1 and less than 10. That might cause a little adjustment at the end of the problem, but it's really not that difficult. Now, the 6 25/100ths times 3 14/100ths. I'm not going to sit here and multiply that out. It's going to take too long. I'm going to go ahead and use a calculator. So I'm going to punch in 6.25 times 3 in the decimal point and 14. And I'm going to get this decimal here. Okay. 19 and 625 thousandths. Now, right now, that is too big to be in scientific notation. I'm not going to worry about it yet, but I will in a second. Now I'm going to multiply the tens, the 10 to the 5th times 10 to the 8th. Well, if x to the 5th times x to the 8th is x to the 13th, then this must be times, I should do the star actually, 10 to the 13th. Now the problem is I'm not in scientific notation. So I have the decimal point here, I need it to be there. So I want to change this to 1 and 6 to 5 like that. I'm not going to round, I don't like to round very often, unless the problem tells me to. Now, I divided this 19 and 625 thousandths by 10, right? To make sure this number stays the same, I'm going to multiply by 10 to the first, right? Right here, didn't I divide by 10? So I have to multiply by 10. Well, 10 to the 13th times 10 to the first is 10 to the 14th. Now, I might have just lost some of you right there, so let me go over that again. Would you agree with me that 2.5 times 10 to the first power is the same as 25? Is it also the same as 25 times 10 to the 0 power? Sure is. 10 to the 0 power is 1, right, Colton? So notice that the coefficient, this 2.5, got bigger. Therefore, the exponent had to get smaller for the numbers to stay equal. If I make the exponent on the 10 get bigger, then this 2.5 will have to become 25/100ths. Yeah. See how simple that is? If I make this even bigger, this 25, and I take it up to 250, well then, this is going to have to get smaller by dividing by 10. And there we go. All those numbers are equivalent to each other. This one's in scientific notation. If I simplify this one here, I get 25. You could call that standard notation, but this is not standard notation. But as a matter of fact, they all equal 25. Here, look at this one, I'll prove it. You've got 250 times 10 to the negative first. Uh-oh, negative exponent, I think I'll take him downstairs. 250 divided by 10 to the first. What's 250 divided by 10? It's 25. So you see, when the coefficient gets larger, the exponent will get smaller by the same multiple. If the coefficient gets smaller, then the exponent will get larger. So let's go back here and see how to do this one. All right, I've got 8 times 1.5. Well, let me do 1.5 times 2 is 3, times 2 is 4.5. Okay? Yeah, that should be right. And then I'm going to do 10 to the negative third times 10 to the negative 7th. Well, that would be 10 to the negative 10th. I'm in scientific notation, so I don't need to convert this one. Okay, notice it's the same thing as doing that black problem there, except you have to watch and make sure you're in scientific notation. All right, division handled much the same way. Hey, if I had 12x to the 7th divided by 6x to the 5th, wouldn't you do 12 divided by 6 and get 2, and then x to the 7th divided by x to the 5th and get x squared, and you'd be on? I'm going to do the same thing here. I'm going to do 2 4/10 divided by 6, which will end up being 4/10. And then I'm going to have times 10 to the 4th power, because 9 minus 5 is 4. I'm not in scientific notation because my number is not greater than or equal to 1 or less than 10 at the same time. Okay, it's not between those two. So I need to make this bigger, right? I need a number between 1 and 10. Okay, so I'm going to multiply by 10 here, 10 to the first. But if I multiply this part of the number by 10, I have to divide this part of the number by 10. And so when I do that, I'll get 4, and I can do that if you like, times 10 to the 3rd. Yeah, it's pretty simple actually. Multiplying and dividing scientific notation is easy peasy. All right, so let me give you a couple to try here. Let's do, I don't want to do 100, sorry about that. Get rid of that number. Let's do 600 times 10 to the negative 3rd, and we're going to divide that by 2 times 10 to the 5th, and we'll give you one more here, a multiplication one. Let's go with 1,650 times 10 to the 2nd, and we're going to multiply that by, I don't know, 50 times 10 to the 5th. Okay, so go ahead and pause the video, try these on your own and see if you get it. Here come my solution. 600 divided by 2 is 300 times 10. 10 to the negative 3rd divided by 10 to the 5th, subtract, I'm going to get 10 to the negative 8th. The only problem is my coefficient part here isn't between 1 and 10. So I'm going to have to divide it by 10 squared. Each of those little scoopies is 10 to a power, right? 10 to the first, 10 to the second. So I'm dividing by 10 squared, or 100. So I'll have to multiply this part of it by 10 squared. When I do that, I'm going to get 3 0/10 times 10 to the negative 6th. All right, now to do this one, let me see. First I'm going to multiply. I'm going to take 1650. I'm going to multiply by 5, and then I'll just tack a 0 on the end. 0, 5, 2, 8. So it should be 82,500, right? And I'm going to multiply that by 10 to the 7th power. I'm not in scientific notation. My decimal point is here, but I need it here. So my number in scientific notation will be 8 2500ths times 10 to the, let's see, what did I divide by? I divided by 10, 10 squared, 10 cubed, 10 to the 4th. So I'm going to multiply by 10 to the 4th here. So that'll be the 11th power, and there you go. Piece of cake! All right, ladies and gentlemen, that is it for multiplying and dividing in scientific notation. Want some practice with that? Well, you can get some practice. All right, Mr. Lawrence signing off. Have a good night, everybody.